Hi, everyone. Thanks for the opportunity today. I think we're running a bit behind, and I have not practiced this talk, so let's see how I do for time. I'm going to roughly go for about 20 minutes and hopefully leave some time for questions. I was thinking about what to talk about today, and I concluded I didn't really know what the right thing to talk about with AI and ML, except that I spent about the last year working a lot on GitHub's Copilot. And I thought it might be useful to share some of what I've learned working in the generative AI space. So when I say AI today, I mean sort of large language models, generative AI, the things that some people are finding remarkable to work with, other people are finding unremarkable to work with. I thought I'd share a little bit about what I think about them and what you can do with them. I think I'll say up front that in 5 years' time, I think the work of research software engineers will be quite different from today. And I think it's a fun conversation to think about that and have a conversation about that, especially in this group. So who in this room has used a generative AI product? By that, I mean like ChatGPT, GitHub's Copilot, other. Okay, very good. Who's tried to build something with like some of those tools under the hood? Okay, some. Who's optimistic about the value proposition of generative AI? Ooh. Who is deeply skeptical? Interesting. Good. This is healthy. Who thinks the work of research software engineers will change over the next few years because of generative AI? Okay, good. Okay, very good. By the way, I realized it's been 10 years since I was at the collaborations workshop, and this is the only evidence I could find that I was at one. That is Simon's head, I'm pretty sure. That is a logo. I'm pretty sure that's an SSI logo. And yes, and I think those are the chairs at the OERC. So it's 10 years. Since then, I was at GitHub when I was at this workshop. Then I left GitHub, worked at the Space Telescope Science Institute for about 4 years, and then I came back to GitHub. So I'm not very imaginative with my career choices, but there we go. So and before we get into generative AI, I just wanted to say very briefly, there's a few things you can do with GitHub, which I think most people will know about, but I just wanted to share. And some of these have been ideas that came up at collaborations workshops, and I just think it's nice to note that these all exist. So you can get a DOI for a GitHub repo, and lots of people have done this. I got this data from Lars Holm Nielsen at CERN yesterday, and about 283,000 DOIs have been made for software releases on GitHub, which I think is pretty cool, and about 60,000 last year. You can also, so this is a real shout out to collaborations workshop, and I guess this was WISPy 5, I think. Anyway, where citation files, lots of people, Software Sustainability Institute and events around and organized by SSI have know about citation files. There's stuff on the blog. GitHub can detect them. Unfortunately, the resolution of the slides is not coming through very well, but there's a citation file linked. If you're looking online, hopefully it'll be better. I promise you the slides are a good resolution elsewhere. But if you put a citation file in your repo, GitHub will add a little UI drop down and will encourage people to cite your work. There's stuff on the in the docs about this, and there's about 35,000 repos that have done this so far, which is kind of cool. And then last but not least, you can now associate your ORCID with your account and not just put it in like you can put other things in your GitHub profile. This actually goes through the OAuth flow. So the ORCID that is on your profile is actually a verified ORCID. There's some docs about that, and that's been done about 26,000 times in the last 6 weeks since we added that. So I'm kind of pleased with that. Anyway, right. So let's talk about AI. So a quick recap of GitHub's Copilot. There are other Copilots. In fact, one of the blessings and curses of being part of Microsoft these days is that Microsoft liked the Copilot name so much they decided to use it everywhere. So you have to say GitHub's Copilot. There's lots of people using it, many millions, and there's lots of students, teachers, lots of open source maintainers using it. It is a generative AI product. It started was released based on a GPT-3 model in 2021 as a technical preview. People write code faster. The code that people write is retained, typically, the vast majority of it. When you ask developers about how they feel when they use it, people feel happier with the work they're doing and pretty confident in the code quality. And people report generally staying more in flow. So if anyone's ever sort of studied software engineering, people are obsessed with staying in flow, staying in close to the task of creating value. So maintaining flow state is something that people care a lot about. Some working assumptions that, from my perspective, I want to sort of share my biases. I would say I'm cautiously optimistic about AI in software engineering. And I think, you know, as you've all proven, the people around you are using it, whether it's something like ChatGPT or GitHub's Copilot, you're using it already. I think there is there is some value here that can be realized, but I think part of the challenge is applying AI to the right problems. I think to some degree Moore's law is likely to hold here, and you know, people are releasing bigger and faster GPUs, and so I think what that means is the things that are hard or slow or expensive today are likely to get cheaper, faster. We're likely to see more AI applied in more places. And people are going to try all sorts of crazy stuff. In fact, if you just, I don't know, I don't read Hacker News anymore. It's too stressful for me. But, you know, people are doing crazy things, trying to do crazy things. Some of them are great ideas. Some of them I think are terrible ideas. And really what I wanted to say is this group of people, I see software engineers, especially in the research domain, as enablers of others. That's how I always thought about my role writing software for research problems. I think we enable others to do great work by ourselves, hopefully doing great work. And I think we should have opinions. We should understand the space. We should understand what these tools are good for, what they're not, and bring opinions to the table. So really, today I just want to share my opinions, and hopefully we can have a conversation around that. Some further framing, again, I think the LLMs are versatile. They can do lots of things and quite well. They are definitely changing how people work. And I think one thing, so if you look on the GitHub blog from yesterday, the thing called a GitHub Workspace has been released as a technical preview now, where you start with a GitHub issue and it breaks down a problem and tries to do a first pass of an implementation based on just an issue. Go try it out. It's, I think, fair to say, with the cost of exploring an idea is trending towards zero, as in human time. And so some things that I think are likely, again, this is sort of how is our work going to change? You know, there's going to be more code in the future. And I think it's going to be written by many of the people who are typically not writing code today. So, for example, the researchers that you support, I think with the aid of generative AI, will be sending more pull requests. That's good and bad, I suspect. So, you know, that I think we should expect that. I think you know, one of the things I like about AI is you can, you know, spike ideas really quickly. And so, you know, building, especially on tools. So I have most experience with OpenAI's models and their APIs, but there's tools like AWS Bedrock, Hugging Face, if you've used that, Replicate AI. There's lots of tools to play around with that have lots of different models. And the last thing I want to do, and this isn't really a talk about responsible AI. I know quite a lot about that. I do a lot of that work at GitHub. There's real work to do to build tools that are actually, I think, acting responsibly and work well. And so there's a great website, rai.ac.uk. You can go and have a look. There's people thinking about this. A lot of sort of what I would call responsible AI is kind of baked into what I'm talking about today. So very briefly, and this looks awful, the thing I've been working on for the last couple of years, and you can't even see it, it doesn't matter. This is Copilot built directly into github.com. And this is me asking questions and it giving amazing answers that you can't see. So there we go. All right. So I said I'm going to share some principles. And the first is no decisions. This is meant to be sort of my opinions on how to build AI products. I think this is built into GitHub Copilot in name, especially. So for those of you who don't know, in planes, the pilot sits on the left and the Copilot sits on the right. And so, and because everyone does this, I couldn't help myself. These are all DALL-E generated images. So draw me a picture of a cockpit of a plane where GitHub's Copilot is in the right-hand seat and a human is in the left-hand seat. Make it the robot a 1950s style one. And so there we go. That's what we got. See, I think there's a hallucination here. It's got 7 engines, which is pretty unusual. So there you go. There's an example of what happens when you ask AI to do things. But I think 7 is quite unusual. I think it would typically be even numbers. But for GitHub, like AI being a co-pilot, being an assistant is a foundational principle of how we think about the product. That means building assistive experiences rather than experiences where the AI is trying to make decisions. In fact, there are no decisions made by Copilot. All the decisions are made by humans. So, you know, we think that it's possible to build AIs that help you go faster, but fundamentally you should be in the driving seat. And let's show a concrete example of that, which brings me to my second principle, which is design for failure. So again, cue ridiculous generative AI picture, make me an image designed to represent design for failure. So now we've got some stereotype of the mad scientist in the lab. But what I want you to think about is, what is the cost of getting something wrong with AI? So, you know, let's think about some tools we could build. So GitHub's Copilot is generating code in the original version, but what if it's explaining something to you? I think one example I saw of an early, what I would say AI fail, was somebody tried to build an app that would give dietary advice to people. Already, yes, grown is the correct response. I think that's incredibly risky, because one of the challenges with talking to AIs is that they can sort of go into, you can get caught in a sort of a line of thinking that just, they go effectively off the rails. And don't know if anyone saw the New York Times reporter talk to Bing Chat early on, where I think it asked him, I think it told him it loved him and he should leave his wife. And this is all widely publicized. These are what was happening there was that the model had this very, very long history that it was just using, and it was very hard to get it to change subject. And it was, you know, they can get really hung up on a particular train of thought. And so, you know, the cost, if you're writing code, especially if there's a human deciding whether to accept that code, I think is relatively low, or can be. But if the cost is, let's say, making a credit decision for somebody's credit card application, that's an incredibly high cost of getting it wrong. So again, thinking about what is it that will happen if you get it wrong. If you get it wrong, can you detect it? Like, can the user detect it? What other systems are in place for correcting for that error? Can you measure, as a person building the system, a good or a bad outcome for the user? So do you have any ways to detect that? So for the original Copilot, so this is me typing. I'm starting to type cosine similarity. This is a code example from my own Python code for something related to the Journal of Open Source Software. Accepting a suggestion here is as simple as you just tab and it writes the next sort of 10 lines of code. Failure here, failure in air quotes, could be a poor code suggestion, one that I don't like, and it's really easy to ignore it. So you just keep typing. And so if you've used Copilot, you'll know this. So the sort of cost of getting it wrong in terms of dismissing a bad suggestion is very low. The cost of getting it wrong if bad code gets added, well, that's a little bit harder to measure. But you know, if we're doing our work as software engineers, then hopefully there's other things going on, like code review by humans, code tests being written, so CI, that kind of thing. So there are other places in the software development lifecycle where we have a chance to catch those errors. But you know, the sort of, this is just a very sort of low example, easy example of sort of an AI product that's generating code where, you know, the cost of the ease of ignoring it is very, very high. You can just keep going. When Copilot initially shipped, people accepted suggestions about 20% of the time and ignored them 80% of the time. So it was wrong or wasn't what people wanted 4 out of 5 times. That still made for a useful product experience. Now it's between 30 to 50%. I just want to spend a little moment talking about hallucinations. Some of you will know this term already. I think one thing I would want for you all to take away is that people sort of say things like, you know, we must control the hallucinations, or we have to get rid of the hallucination. I'm not an AI researcher. I have not built complex neural networks, but I think it's important to realize that sort of large language models, the whole point is they hallucinate. They're always hallucinating. They're always making stuff up, but sometimes what they make up is useful. So as long as you think about it in that way, that the goal is to steer them into doing something useful rather than saying these are not, these are sort of a occasional issue, then you're in a much better headspace. So they are unavoidable, but you can reduce them through a variety of techniques. You can tune custom models, you can provide context, you can do lots of different things to make the hallucinations, bad hallucinations that cause issues, less common. But just as a ballpark, you should assume that there's going to be something very, very subtly wrong about half the time if you haven't done any work. And then more severe hallucinations can be sort of 10% of the time. So again, thinking about the cost of getting something wrong, how you would detect it if you did, that kind of thing. There are tons and tons of techniques for mitigating hallucinations, and this is, I would say, a very active area of research. And again, they are unavoidable. So think about, again, what you're building, how to build systems where if you have them, where either the cost of them is low, or that you have other techniques for detecting them. Which brings me to my third principle, which is grounded in reality. So one of the things that people do to reduce hallucinations is they provide context to the models. This is apparently what DALI thinks retrieval augmented generation looks like. So one of the things you can do, and you will have heard this term, I think some of you, is this thing called RAG. People talk about retrieval augmented generation. And so this is where you effectively give the model that you're using some information from your system, from your world. And so this is really, I think, the sort of, in terms of controlling the outputs of large language models, this is, I think, the best bang for your buck. It's not super hard to do. A basic version of this, and lots of people are building infrastructure to make this easier. I would say there's many alternatives, one of which is like build your own model. I think friends don't let friends build their own large language models typically. It's not a good use of your time. There is fine tuning, which is actually much easier and can work for very niche ideas and niche tasks. One example at the CZI workshop last year, we fine-tuned a GPT-3 model to detect mentions of software in bodies of papers. So the first version of that was just turned out to be a proper noun detector, which wasn't useful. And then we gave it a few thousand examples, and it actually was pretty good at finding, like, this is software. And so finding examples of how people were expressing the fact that they had used a tool, but where it wasn't cited. And that was kind of fun. So, you know, fine tuning with a few examples can really help. So, so the retrieval augmented generation roughly looks like this. You have some kind of model, somebody asks a question, and you have, obviously, you've told the system how you want it to behave, and you've got the user query, and then you take the user query and you go and retrieve information to augment the generation. So you end up coming back with retrieved context that gets supplied with the prompt, with the user query and the retrieved context, and then that then allows the model to give a better answer for the question that came from the user. So this, you know, the stuff that you're retrieving is your stuff. So it could be documents, it could be code, it could be conversations on GitHub, it could be a whole bunch of different things. And so there's lots of people trying to figure out how to build services that make that retrieval step easy. And you can do lots of clever things at the finding stage. You know, you can do keyword search, you can do vector search, you can do lots of different similarity searches, but effectively think of this as you're sort of giving the model the most relevant information that it should use when it's synthesizing response. This is a good way of grounding the model, so it gives, you know, safe and accurate answers. But, you know, one of the things that we do a lot is you can also tell it that it should cite its sources. So just like you would ask a human to, why did you say that? Well, what's your sort of proof that that thing is true? Then cite your sources. But just a warning, like hallucinations, it can also make up sources. So if you've ever asked these models to, you know, tell me where you found that information, it makes up a citation that looks very convincing. In fact, you've probably seen this, people submitting papers or legal briefs where they ask it to find legal cases that would support their line of thinking, and it makes up answers. So a thing that you need to do if you're going to build tools like this is you need to check that the citations that it's giving are real. So that's an extra step that you can do, and that's one thing we do a lot for Copilot. So when it does cite something, you do a final pass through to say, is everything that's being cited here actually real? And I think one of the things to take away about retrieval augmented generation is that it allows you to take sort of what are typically called like foundation models or base models, things like GPT-3, GPT-4, Claude, Opus, all the things like that. It allows you to take a base model and make it into a thing that can talk about your domain. And so this is especially useful if you're working on a niche area where the material that's being discussed isn't knowable from public information. It's very niche research area or something like that. But retrieval augmented generation is typically much cheaper than doing anything like building your own models or fine tuning, and it's fairly easy to get working. And again, I can't really show you this here, but where I'm talking to Copilot and I'm asking about something on a repository here, and it's retrieving the issue thread and all the context there and using that to generate a response. So that's an example of that there. Okay, so I'm nearly done. So fourth, I think, is invite only. So this is the prompt here would draw me a picture of a robot fighting a dancing paperclip. So hopefully people will get that reference. As Copilot is brought to you by the company that brought the world Clippy. So in some sense, I think this is really important. This is an opinion I have that really the natural language to code bridge is one that is actually pretty powerful. So if you've used Copilot and you've used the chat thing where you can talk to the AI and ask it to explain stuff, I think you can have some remarkably good experiences with that, and you can have some poor experiences too. But I think there's a lot of potential value to unlock there. And so, but again, we don't want, I don't think the tools are good enough yet to just sort of insert themselves into the experience without being invited. So one way I also think about this is, only surprise users if you can delight them. And I think my base assumption is right now is that generative AI is good, but it's not nearly good enough that you can just say, I can solve this problem for you, because there's a chance that it won't be able to. So again, I think it's an invite only thing in my experience right now. And then the last principle is explain like it's me. And so I think this is one of the most exciting things about language models, is that they can personalize how they respond based on the question that you ask. So some of you will know ELI 5, explain like I'm 5. So I'm trying to understand something, explain it like I'm 5, explain it like I don't, explain it like I'm explaining it to my mom or my dad. Or so this sort of explain like I'm 5, explain like I know lots about this already, like make it harder. Like I know about JavaScript, I know about TypeScript, don't explain that stuff. I made up my own one, and this is back to my PhD, explain like I'm a physicist that doesn't know much chemistry. You can ask the models to customize how they respond to you based on your preferences. And I think this is incredibly powerful. And so I think this is where a lot of the value is, that kind of an inherent thing based on these language models, the fact that they can, I've just been trained on a lot of text from the web, is that the personalization is a key value proposition of these. And so this is a thing I think that is currently sort of assumed to be currently a thing that I think is a big gap between people who just do sort of cursory play with generative AI and actually are really leveraging them to as part of their core work, is that they've realized that they can really steer the model into behaving in a particular ways. And so these are generally just prompt changes where you can encourage the model to behave in particular ways. But this is, I think, is a huge opportunity. And this is why I think people are tempted, and I think I'm cautious here, but I think there is opportunity here as well. This is why people think about these tools for explaining things to people, personalized learning experience, that kind of thing. I think there's you can steer, tell it things, don't explain that bit to me, go deeper on this, or skip to the next step of a tutorial because you already know the first bit. So there's a lot of opportunity in personalization, I think. So I will stop there. So these are my 5 principles. This is some lessons I've learned over the last year or so working on generative AI. I'm happy to see a healthy mix of excitement and skepticism in the room, and I thank you for your time. Thanks so much.
Thanks a lot, Arfon. We'll have a look at the questions on Slido in a moment. Okay, let's start with the first question at the top.
Sure.
Is it environmentally responsible to use these tools automatically?
I'm assuming by automatically, I guess we can't do a clarification, can we, unless somebody asked him. Oh, yeah. Oh, yeah. So the thing on the screen that I showed. Oh, so that was it only did it if you asked. It doesn't automatically do it. So I agree. It's incredibly expensive to do these things automatically. So that's not quite what I was saying. Mm-hmm. Yeah. Yeah. No, I agree. I mean, I think LLMs are expensive to run for sure. And I think the environmental impact is not insignificant. I would say if somebody wants to have a breakout on this, I have a lot to say about this. I have a lot to say about traditional HPC centers and these articles about the most green programming languages. I think there's lots to unpack there. So because I actually don't think that conversation is particularly good, but I agree they're very expensive. And I mean, in reality, a lot of the good news is they're expensive. So there's very little incentive for companies building these products to just do things at scale automatically because they can't afford to. Sure. Yeah. I mean, I think there's lots of perspectives on this. I'm worried about some of the things you're worried about, I'm sure. But I don't think I can give you an answer better than I think it's a good discussion to have. Yeah. Oh.
Yeah, we need to share. I'm sorry. Great. Okay. Let's get to the next question. Not particular to Copilot, how do we look at cost of injection of content by LLMs on the web or unchecked usage by folks? AI-generated research, polluting the web, bots, fake research, mass-generated AI content for click revenue. Do we have tools, policies to verify, check such contents?
Yeah, I think this is a question for society, honestly, at large. I don't think this is a problem that we think about related to code. And I have questions about what it means to have an AI train on itself. That seems like something that doesn't seem obviously good, but I think there's also other reasons to think that could be good, in the sense like if you're steering the AI to generate more secure code, then having less, there's potentially some convergence of some solutions in some space, but that's an aside. In cost of injection, I think one of the things that, going back to sort of retrieval and verifying sources, I think it's critical to not provide answers without citing your sources. So I think that's a practice that we know pretty well already. I think there's a lot of work going on around verification of individuals and sources. I'm pretty sure BBC shipped a thing around image provenance a few weeks ago, or there's something around where did this photo originally get taken before it was shared and used in news. I think, generative content is going to be like a really big problem space for society to work on at large. So, yeah.
Okay. So next question. Do you think that RSEs will end up fixing more wrong code when scientists are using ChatGPT to generate large blocks of code that they don't realize regarding wrong, rather than copying short snippets from Stack Overflow?
Yeah, it's a good question. I mean, I think there will be more code. There'll be more code review. I think this is, I mean, Neil and I were just chatting about this morning about, I don't think we can know what will actually change about RSE's roles right now. I think the things that are pretty important and won't go away will be reviewing of code and testing of code. So I think the things that we would say make for good software engineering practice will arguably become even more important. Fixing more wrong code. I guess, I don't know on the wrong versus Stack Overflow. I think I mean, I have feels about Stack Overflow as well. So I think there will be more code to review. I don't know if it will be more wrong or need more fixing. I don't think I know yet. I'm not sure anyone can.
All right, thanks a lot. We're going to wrap up here, and I guess there will be a break, right?
Yes, we are behind schedule, but we have planned the sessions after the break with a little bit of buffer. So thank you, everyone. Thank you, Nadine and Arfon, for Keynote 1. And thank you, everyone online, for bearing while we were figuring things out live.